Hi, in this video, we will try to explain the fission and fusion process as an important nuclear reaction in producing huge amount of energy. To start our discussion, let me ask this question to you. What first came into your mind when you hear the word nuclear? Well, some of you will say it is dangerous because it is associated with a nuclear weapon as an explosive device. And some of you might also say it is useful because of its different nuclear applications, like production of energy using nuclear power plant. If you have these answers, you are correct. In this video, we will try to explain the concept behind this event, on how nuclear weapons and nuclear power plants produce a huge amount of energy. Moreover, we will also explain the processes involved behind the continuous emission of the sun's energy. To explain further the idea of how huge energy was produced in a nuclear reaction, we should be familiar with the idea of understanding the atomic nucleus. The study of the atomic nucleus is called nuclear physics. Understanding the characteristics of the atomic nucleus reveals the significance of this in our modern society. It was significantly contributed to the different fields of applications, like in technology, industry, health, and source of energy of the society. Fission process was simply the splitting of a large nucleus into two intermediate-sized nuclei with the emission of neutrons and the conversion of mass into energy. For example, uranium-236 fissions into two smaller nuclei like xenon and strontium, emits several neutrons and releases energy. If all of the emitted neutrons hit another 235 uranium nucleus, this results in an increasing number of emitted neutrons, fission reactions, and energy release. This is called fission chain reaction. The spontaneous chain reaction of fission process sustained the production of huge amount of energy in a nuclear reactor of a power plant. Same process occurred during the explosion of a nuclear bomb. On the other hand, fusion is the process in which smaller nuclei combine to form larger nuclei along with the release of energy but does not require a critical mass. Fusion is the source of energy for the sun and other stars. In the sun, the fusion process produces a helium nucleus from 4 protons, which is hydrogen nuclei. An example of this is the deuterium and another deuterium fused to produce much heavier element called helium-3. The spontaneous process of formation of heavier nuclei serve as the fuel of the sun to sustain its light energy that can be harnessed using solar panels. In both processes, mass defect during the reaction was considered, which resulted to a large amount of energy produced. Mass defect was profoundly introduced by Albert Einstein with his famous formula E is equal to mc squared, where E stands for energy, m stands for mass, and c stands for the constant value of speed of light. Mass defect unit can be expressed in mega electron volt, which equal to 1.60 times 10 raised to negative 13 joules. Calculation with Einstein formula E is equal to mc squared have convinced many scientists that small amounts of mass that are lost in nuclear reactions could be a tremendous source of energy. This idea was applied to create atomic bomb and much more useful applications like nuclear and solar energy. Now, let us have a summary of what we have discussed in this video. Remember that nuclear physics is the study of characteristics of the atomic nucleus. Nuclear processes involved in the production of nuclear and solar energy are fission and fusion respectively. In both processes, the concept of mass defect was applied, explaining why both processes produced a huge amount of energy.